So in this video, we're going to talk about what are called finding absolute extrema. And if we have a graph, we've been talking about finding relative extrema. Then if we call this graph f of x, then we've been saying that this point here is a relative max, this point here is a relative min, and this point here is a relative max. But in this section, what we're going to talk about is what are called absolute max and absolute min, which we call absolute extremes. And so the absolute max and the absolute min, in general, are going to be the biggest y value and the smallest y value the function can take. So in this particular case, we can see that right here is the absolute max. And because this function goes to negative infinity forever, it's going to not have an absolute min if we allow the function to be defined in the entire interval negative infinity to infinity. But let's say that instead what we do is we close the interval. So I'm going to say I'm just going to look for absolute maxes and mins on this interval. Maybe I'll make this extend down a little further. Then what we would find is that on this interval, we can talk about the absolute min. So what we're going to do is we're going to say that if f of x is continuous over a closed interval, which we'll call AB, then it must have an absolute max and min. Okay. So if we were to look at this graph here, then we could say that this point, its y value, is going to be the absolute min because that's the smallest value that this function takes on over this interval that we'll call AB. So the way that we'll solve for absolute maxes and mins is we're going to look at all of the relative maxes and mins, and we're going to look at what the y value is for f of x at the endpoints. We're basically just going to compare all of those and figure out which one is the overall smallest value and which one is the overall biggest value. So let's take a look at an example of that. Let's say that, for example, we have f of x equals x cubed minus 3x plus 2. We want to find the absolute max and min over the interval minus 2 3/2. Okay, so here's what we're going to do. Is our first step is going to be to find the critical values. So that's going to mean that we're going to take the first derivative and determine when it's equal to 0 or is undefined. So if I say f prime of x is 3x squared minus 3, then what I want to do is figure out when this is undefined, and it's never undefined because it's a polynomial. And so we're going to check to see where this equals 0. And so I'll do this by factoring. I'll factor out a 3, so it looks like this. Divide both sides by 3, and I get x squared minus 1 equals 0. I can factor this into x minus 1 times x plus 1 equals 0. And this says x minus 1 equals 0 or x plus 1 equals 0. So x equals 1 or x equals minus 1. So an important thing to consider is whether or not the critical values are lying within our interval. And in this case, our interval up here is from minus 2 to 3/2. And both x equals 1 and x equals minus 1 are in the interval. So we're going to check to see what does f of x equal at the endpoints, which is minus 2 and 3/2, and also what it equals at the critical point, x equals 1 and x equals minus 1. So what we can do is we can look at f of minus 2, which is the left endpoint of our interval, and if we say that f of x equals x cubed minus 3x plus 2, then f of minus 2 means that we're going to have minus 2 cubed minus 3 times minus 2 plus 2. and that's going to equal, if we plug that into our calculator, that's going to equal 0. So that's what the function equals at the left endpoint, and then I'm going to check the critical value at x equals -1, and that's going to be -1 cubed minus 3 times -1 plus 2, and if we plug that into the calculator, that gives 4. Then I do f of 1, and that's 1 cubed minus 3 times 1 plus 2, which also gives me 0. And then I'll do f of 3/2, which is the right endpoint, and that's 3/2 cubed minus 3 times 3/2 plus 2, and that equals 7/8. All right. So now what we do is we basically just compare all these y values and see which one gives us the biggest. And in this case, that's going to be this here number here, 4. So this is what we're going to call our absolute max. And if we check the critical values and the endpoints, we find that there are 2 cases where y equals 0. And so because those are the same, we're going to say that the absolute min is equal to 0. Okay? So even though it appears twice, we're still just looking for the y value, and from this calculation, this says that the smallest y value we have in our interval is going to be y equals 0. So that's going to end up being our absolute min. Okay, so this works out pretty well for the most part, and the key here is to find the absolute max of a function that is continuous over this interval. What we're going to do is we're going to compare the y values of f of x at the endpoints and critical values, and then the largest value is going to be the absolute max, and the smallest value is going to be the absolute min. Okay, so this should be helpful for the quizzes that you have to do.